Today we are going to learn about Pandas Secrets, transforming data with GroupBy. We'll explore mastering advanced data transformation techniques using the powerful GroupBy function, enhancing your analytical skills in Python.
Welcome to this educational journey on unlocking the secrets of Pandas GroupBy. At the heart of data manipulation in Python, the GroupBy function is pivotal for aggregating, summarizing, and generating insights from complex datasets. It empowers you to transform raw data into meaningful insights, providing the backbone for data analytics and science. Whether you're dealing with large datasets or seeking to generate detailed reports, understanding GroupBy is crucial. This video will guide you through the various facets of GroupBy, from basic aggregation to advanced transformations, ensuring you harness its full potential in your data projects.
Let's dive into the world of basic aggregation functions. In Pandas, aggregation functions such as sum, mean, and count are your go-to tools for summarizing data. They provide a quick and efficient way to get insights into your datasets. For instance, using the sum function, you can determine the total sales per product category. Similarly, the mean function allows you to calculate the average rating of items in a dataset, providing a glimpse into customer satisfaction. The count function, on the other hand, helps in identifying the number of entries per group, which is invaluable for understanding data distribution. These functions are not only easy to use but also form the foundation for more complex data manipulations. By mastering these basics, you'll be equipped to handle a wide range of data analysis tasks, paving the way for deeper insights and informed decision-making. While basic aggregation functions are powerful, there are times when you need more tailored analysis. This is where custom aggregation functions come into play. By creating custom functions or using lambda expressions, you can address specific analytical needs that standard functions can't. Let's say you want to calculate the weighted average of sales based on product importance. By defining a custom function, you can easily achieve this level of detail. Moreover, you can combine multiple aggregations, such as sum and mean, in a single operation, providing a comprehensive view of your data. This flexibility allows you to adapt your analysis to various scenarios and datasets, ensuring that the insights you derive are both relevant and actionable. Custom aggregation functions enhance your ability to transform data in meaningful ways, making them an essential tool in your data analysis toolkit.
In real-world data, we often encounter hierarchical structures that require multi-level grouping. Pandas GroupBy is equipped to handle such complexity by allowing you to group by more than one column. This approach is particularly useful when working with datasets that have nested categories. For instance, consider a dataset of sales transactions with columns for country, region, and product. By grouping data first by country, then by region, and finally by product, you can generate detailed insights at each level of the hierarchy. This capability is crucial for businesses seeking to understand trends and performance across different segments. Multi-level grouping not only facilitates comprehensive analysis but also enhances your ability to generate detailed reports, ensuring that decision-makers have the information they need. By mastering this technique, you can unlock the potential of hierarchical data and transform it into actionable insights.
The apply function in Pandas, when used alongside GroupBy, provides unparalleled flexibility for transforming data. This combination allows you to apply any custom function to each group, enabling complex calculations and modifications. Imagine you need to normalize data within each group or apply a specific transformation to values based on group characteristics. With apply, you can easily implement these transformations, leveraging the full power of Python functions. Whether you're calculating z-scores or adjusting values based on external criteria, apply empowers you to conduct intricate data manipulations efficiently. This capability is particularly valuable in data preprocessing stages, where preparing data for analysis is crucial. By mastering the use of GroupBy with apply, you can streamline your data workflows, ensuring that your datasets are both clean and ready for deeper analysis. When working with large datasets, performance becomes a critical consideration. GroupBy operations can be resource-intensive, especially with complex transformations. To optimize performance, it's essential to use efficient data types and structures. For instance, converting object types to categorical can significantly reduce memory usage, speeding up computations. It's also important to minimize unnecessary calculations by filtering and cleaning data before applying GroupBy. Balancing memory usage and processing speed is key to ensuring scalable operations. By following best practices, such as using vectorized operations and avoiding loops, you can enhance the efficiency of your GroupBy tasks. These strategies not only improve performance but also ensure that your analyses remain robust and responsive, even with growing datasets. Understanding these considerations will empower you to handle data transformations effectively, regardless of scale. To illustrate the power of GroupBy, let's explore a real-world case study. Imagine we're analyzing customer purchase data from an e-commerce platform. Our goal is to understand spending habits and identify high-value customers. We begin by using GroupBy to aggregate purchase amounts by customer ID, calculating total spend and average order value. Next, we implement custom aggregation to identify the most frequently purchased categories for each customer. Throughout this process, we encounter challenges such as handling missing data and ensuring performance efficiency. By applying the techniques discussed, we overcome these hurdles, transforming raw data into actionable insights. This case study not only demonstrates the practical applications of GroupBy but also highlights its role in deriving meaningful insights from complex datasets. By following this approach, you can apply these lessons to your data projects, enhancing your analytical capabilities.
Despite its power, GroupBy can present challenges that may hinder your data analysis efforts. Common issues include performance bottlenecks, especially with large datasets, and errors arising from data type mismatches. To address performance issues, ensure your data is clean and optimized for processing, using efficient data types and minimizing unnecessary calculations. Data type mismatches can be resolved by explicitly casting columns to the appropriate types before applying GroupBy. Additionally, conflicts can arise when grouping by multiple columns with mixed data types. To avoid this, ensure consistency in your data structure. By understanding these common pitfalls and implementing solutions, such as using debugging tools and testing small samples, you can confidently navigate unexpected scenarios. This knowledge will empower you to handle GroupBy challenges effectively, ensuring that your data analysis processes remain smooth and productive.
As we conclude our exploration of Pandas GroupBy, it's clear that this powerful function is indispensable in the realm of data analysis. From basic aggregations to complex transformations, GroupBy offers a versatile toolkit for generating insights and summarizing data. Its adaptability to various scenarios, from hierarchical data structures to custom aggregations, makes it a must-have skill for any data professional. We encourage you to continue practicing these techniques, applying them to diverse datasets, and exploring further learning opportunities to enhance your expertise. Thank you for joining us on this journey, and we wish you success in your future data endeavors.